Good afternoon, everyone, and welcome to our third and final webinar in our Finance and Insurance Learn at Lunch series. Today, we are joined by our guest speaker, Sarah Lee, who is a Senior Cloud Solution Architect from Microsoft, who will be talking today about how you can deliver operational excellence with Azure tools and services for your finance and insurance business. So without further ado, I will hand over to Sarah.
Awesome. Thank you for that introduction, Adam, and welcome to everybody that is joining us today. As Adam said, this is our third webinar in our series, and if you've been tuning in the previous webinars, then you'll know that our kind of theme is talking about how to adopt things in Azure and how your kind of mentality and thinking around architecting and doing things and maintaining your solutions in the cloud is slightly different than on-prem. And today is focusing on operational excellence and explaining what that means and how that mindset has changed in the cloud. Now, I'm happy to take questions, folks. Please use the chat or the Q&A box, whichever one is available to you in Teams today, and we'll get to them at the end of the session. So yeah, happy to take your questions, so get typing while I'm talking away. So today we're going to be talking about operational excellence, and the agenda is the operational excellence principles. So let's dive into those and explain what that means. So operational excellence sounds a bit like a buzzword, and I've said it a few times now at the start of this webinar, but operational excellence at Microsoft is basically guidelines to help you create an environment that is sustainable, using various different building and deploying and maintaining processes for your workloads, and understanding how to build in automation and monitoring and testing in your environment to really make it manageable and sustainable in the long run for your business and your department as well. So let's dive in and talk about those guiding principles within operational excellence. Now, the first one is optimize your build processes. Now, whether you're building software or whether you're deploying your resources as code, you have to think about how to do that in a sustainable way, how to do that in an optimized way. I think if we look back 10, 15 years ago, we were probably all sat in data centers and building servers physically, building resources and plugging in network cables. And that was onerous and not very sustainable. And it often meant that your most senior engineers were walking through next, install wizards. But when we move now into the cloud, we have the ability to use infrastructure as code to try and speed up the processes of deploying resources. And that's something that does take a lot of kind of mindset change and also knowledge transfer as well. But if we think about it now, and if we look at this report from GitHub that they released in 2022, they said that they are noting an increase in infrastructure as code practices across all of their GitHub projects, especially in their open source project. And for me, that's massively encouraging because, as I said, years ago, we used to do the builds manually and we would be sitting inside data centers. And for a lot of people, and for me as well, when I was adopting the cloud, it was scary to think that I had to start to learn code. I had to start to learn how to write code to deploy servers instead of actually being in the room with them and deploying them. And it can be quite a clash. I still talk to customers nowadays who are frightened to adopt infrastructure as code because they think it's going to do away with their job, or they're not people who enjoy writing code. I am someone who does not enjoy writing code. My brain does not work with looking at code. It doesn't come easy to me, and I have to work very hard at doing that. So trying to learn infrastructure as code was a big barrier for me, but I'm pleased to say that last year I spent a lot of time learning Azure Bicep, and this year I'm learning Terraform. So I'm well on my way to trying to become someone who's comfortable in that space and being able to look at how to use those new skills for automating things in the cloud. And along that way, I've learned a bunch of other things as well. I've learned more around DevOps and how that can help you provision things in a much faster and much more reliable way. Infrastructure as code can help us free up ourselves as engineers, as experts, and allow us to do more bigger projects, to look at other things in our environment, to allow us to deploy environments in a reliable and consistent way. So our production environment and our development environments are mirrors of each other, and they work seamlessly together as well. Well, as I said, on my journey of infrastructure as code, I've been learning DevOps and how that integrates into infrastructure as code, and using pipelines, using automated deployment can really help me as a person to do those consistent ways and trying to make my code better as well. We can introduce testing into our pipelines where we can look at trying to eliminate hard-coded secrets, so username and passwords inside our code so we can be better with our code. It also helps me avoid misconfigurations as well. So maybe the business that I'm working with doesn't want to deploy things with port 80 open. That's a standard one that we get requests for. So we can have tests set up so that we are not deploying code that allows that port to be open. So again, it helps you in your learning journey and helps avoid those misconfigurations from a business point of view. So infrastructure as code is one of those things that I encourage everybody to learn. Whether you learn one, whether you learn two, it is something that is key to building that operational excellence when you're looking towards the cloud. It's a much used skill. And also look into DevOps practices as well. Learn some integration tools, learn some of those CI/CD pipeline tools and understand how you can leverage them and build on your skill set, again, to make your life in the cloud and your business much easier and more efficient as well. The next kind of pillar in our operational excellence is operational health. So this is the implementation of systems and processes to monitor aspects of your workloads. If you don't know what's happening in your environment, how can you react to it? How can you improve? How can you make things better for your business? And for me, this is a big conversation with a lot of organisations. They either have too much alerting and completely ignore it, or they don't have any at all, and that makes it hard for them to react to things or be able to troubleshoot things when they can't, when there is issues inside their environment. So getting that balance right is key to having that operational health pillar really nailed down. Now, my colleagues here at Microsoft have been focusing on this lately, and they've come up with this 6-step approach to monitoring. Now, this could be a presentation on itself, but let's run through the steps just to give you some idea of what those 6 steps should be. Now, the first step is to document the architecture of your workload you want to monitor. List all the services that make up that solution. Step 2 is to understand what monitoring you can get for the services you listed in step 1. So, for example, if you're monitoring, say, a VPN gateway, you can get figures and metrics on things like average bandwidth, tunnel ingress bytes, and much more. So make a note of those and then understand what metrics are captured and where. So where do those metrics go? Is it inside Azure Monitor? Is it activity logs? Is it in Network Watcher? Where do those metrics actually get stored? So as you understand not only the metrics that you can capture, but the tool that captures them for you. Step 3, you've gathered a lot of information now, so it's time to start to think about what your requirements are. Which ones of those metrics that you captured in step 2 are actually important to you? Which ones do you need inside your environment? Build a user story. So what do people need? What information do they need? Why do they need it? And how do they need it? Do they need it in a dashboard because they want to glance at it when they walk into the office in the morning to understand if things are green or red? Or do they need it in an email alert and then it goes into your ticketing system and then it can be processed that way? Build up that user story for each metric that you need. Step 4, you've got your requirements. And you've got where all those monitoring things go. So now it's time to actually start converting that into a kind of process for yourself and understand where you're going and how you're going to implement that in your environment. So these are the deliverables around what's happening. But we've now started to populate our backlog stories. So we now have these tasks that we have to implement around what's happening in our environment. So we've defined what we need from a monitoring point of view. Now we need to put that implementation plan in process. So build the tasks that need to be completed so that you actually have all of the monitoring that you need in place. And last but not least, you have to manage your data. When you're capturing all of these logs and monitoring, it can be overwhelming from a cost point of view if you store them forever and you have all of them in a data storage account, for example. So what do you need to retain them for? Do you need them for 30 days? Do you need them for 60 days? Do you need them for 90 days? Do you need them forever for auditing and compliance needs? Think about how you're going to manage that data. Think about how you need to access it. So does it always need to be readily available, or could, after 30 days, you archive it somewhere else? So that if you needed to look back further, you do have that data, but it's potentially in another place for you to help maintain costs as well. So maybe you don't have to have it as a hot access within an Azure storage account. It could be in an archive storage account where the costs are a lot cheaper. So yeah, that's the 6-step approach that my colleagues have been devising and have practical workthroughs to help you go through all of this. But as I said, it can be a presentation in itself, this. But what I've done is actually put some links to more detailed information about this 6-step process in the link below. So at the very bottom of my slides, you'll see a link which has a bunch of resources that you can go off and have a look at. And in it, as I said, is this 6-step approach in much more detail with some practical examples and walkthroughs as well. So another operational excellence pillar is recovery and failure. And this one should not come as a surprise to you at all. This is something that we needed in our on-prem environment, and it's something that we still need inside our cloud environments as well. And this is really to ensure that whatever environment you're operating can recover from an outage or a disaster and deal with accidental issues as well. Now this slide I'm going to show you, you'll think that is kind of basic. However, I still do come across some people who are not sure about when they have to have disaster recovery and when they have to have backup and when both are needed. And I think this is key. This is something that has changed a little in terms of what we're doing inside the cloud versus what we did on-prem, but we still need both of these. We still have to have a disaster recovery plan, and we still have to have backups depending on the workloads that we have. Your disaster recovery is the plan and process you have in place to recover something when it's catastrophic. So if you have a flood or a storm or some massive outage like that, that's when you potentially need that disaster recovery process and plan in place. And backup is there to help restore lost data or corrupt data, or again for compliance needs where you have to maybe query data that was there for 7 years in some of the financial industries as well. Both are required, and you really can't forget about them in the cloud. When we look at some of the stats, and I know these stats, if you can read the small print on my slide, it says it's from 2020. However, I think they're still relevant in terms of what we're seeing and anecdotally what customers are telling me about their environments. The first stat here says that 93% of organisations had been attacked by malware or ransomware. And that's pretty scary, I think. 93% of organisations took part in the survey had been attacked. That is scary. And that shows the emphasis of why you need to have those protections in place in case something like that happens to your organisation. The other scary stat on this slide is that less than 50% of applications are protected by disaster recovery plan, meaning many organisations are not prepared to respond to a large-scale recovery situation. That is scary to think about. What happens if something goes wrong in your environment, whether it be a malicious attack like malware or ransomware, or an environmental issue? Your applications are not protected. That's going to cause a lot of stress for you. And I think it's something that people need to be mindful of and have that shared responsibility model in their head when they move towards the cloud. Understand what is Microsoft's responsibility in terms of Azure and what is yours as an end user of the platform and where your responsibilities lie across the platform. When you are looking to design applications and workloads in the cloud, design for high availability should be right at the top of your requirements when you first do a design. And when we look at Azure, there are many features you can take advantage of to make sure your applications and infrastructure can recover from failure, as well as having that disaster recovery plan in mind. So here we've got a few features on this diagram. We've got disaster recovery and backup on there. However, we also have things in Azure like availability sets. Now, availability set is a logical grouping of virtual machines that allow Azure to understand how your application is built to provide for redundancy and availability. Within a single data centre, the use of availability sets can increase the SLA from 99.95%, by protecting a set of virtual machines, ensuring they will not be on the same hardware. If we look at that from a region point of view, virtual machine workloads can be distributed across availability zones to increase the SLA to 99.99%. So that's quite interesting in terms of architecting it as well, and that should be part of your disaster recovery plan, architecting for high availability for some of those workloads that are mission critical in your environment. We've also got availability zones across a lot of our regions. So these are unique physical locations within our Azure regions. Each zone is made up of one or more data centres with independent power, cooling and networking. The physical separation of availability zones within the region limits the impact to applications and data if there's a zonal failure, so such as those large-scale floodings or major storms that I talked about. So again, taking advantage of some of the infrastructural disaster recovery availability inside Azure can really help you with that disaster recovery plan. We also have region pairs, and that is a relationship between two Azure regions within the same geographic region for disaster recovery purposes as well. So if one of the regions were to experience a disaster or failure, then the services in that region can automatically fail over to the other region in that secondary region. So the pair help each other. If one goes down, you can use the other one as well. Of course, there are some costs associated with using some of these services that then put them into a premium tier. However, it's all about making sure that you have the right things in place to be able to understand how you're architecting for a disaster or a recovery as well. Continual operation improvement. Achieving operational excellence means your team needs to embrace continuous changes and improvements as well. Continually evaluating how to do something inside your department is maybe not something we're used to. I know when I think back to some of the scenarios I did on-prem, we would put something in and we would just keep it like that for years. That was the process that we had. If it worked, we didn't evaluate it again. However, in the cloud, things are constantly changing. New features are coming out, new best practice, new guidance on how to architect things are always happening. So there has to be a continual learning process, a continual evolving process as well in the cloud. And also, as businesses evolve and change and adapt to their markets as well, you have to adapt to how you're architecting within the IT department as well, and try and grow with your business to help meet its needs. And this is why evolving your processes is quite important. So some of the things you should be looking at on a semi-regular basis is defining owners and playbooks for processes and tasks. Do you have owners for your disaster recovery strategy? Is there someone in charge of making the call about when you would actually fail over and initiate a disaster recovery plan? Does that all fall on the head of one person, or are there several people that are looking after that? Do you have owners for each application that then, as a committee decision about when you fall over to disaster recovery? These things should be decided and defined and continuously looked at. Are the processes working or are they not? Also, you should be testing your operational procedures. The big one, an example that I think a lot of people think about is your backups. It's very well having a backup strategy, but do you test them? Do you actually make sure that you know how to back up? What are the nuances of these services and applications that you have the backup data of? Can you actually restore, and how quickly does that happen? And does it happen quickly enough for the organisation's needs? I think back to when I worked very first time in IT, my job was on a help desk, and we regularly had scenarios where we'd work through some of our playbooks. I remember one of the scenarios was I was walking into the office one day and the head of IT greeted me, which is never a good thing. And she said, "The building is flooded, you need to proceed to the emergency procedure office." And I looked behind her, the office was empty, there didn't seem to be a flood, and her face told me that this was definitely not an April Fool's and I had to take her seriously. So I went to our emergency office and everybody was in full disaster recovery mode. They were testing how we would handle if the office actually had flooded and our data centre was flooded as well. It uncovered things like our emergency break glass passwords weren't up to date. They weren't where they should be. We didn't have all the manuals and the processes that we needed in our emergency office. So it really uncovered some of the things that we thought were in place. We thought we were in a comfortable position, but we actually weren't. That experience has still stuck with me some 18 odd years later, but it prepared me for when actually we did have a massive outage and we lost our data centre and how to react to it. We even did small tests, like we said that the phone lines were down and how we would actually handle that as a help desk and how we would interact with the business. These small things do affect your day-to-day job, so make sure you're testing it, make sure you're putting your staff in these situations where they can have the luxury of maybe not performing to their best, but it builds on those processes and experiences again, so that when it does actually happen in real life, they are much more prepared for it happening. Root cause analysis is something that, again, we do quite often at Microsoft to help improve our situations and solutions. I think if you think back to earlier this week, we had an outage at our West Europe data centre, and there was a lot of issues around that for our customers, and we will be going through a root cause analysis for that, and we will be feeding that information we've gained from that outage back into future operations. And if it happened because we didn't do something right in our routine maintenance, then we will try and improve that process in the future, and you should be doing the exact same thing. If something went wrong when you were patching your servers one evening, you should do a root cause analysis to understand what caused it and how to mitigate that in the future. These are the things that you constantly have to evolve and constantly be thinking about improving. When we talk about the cloud, you often hear people talk about modern architecture and how to do cloud native architecture as well, because there are some things that are massively different around how we design our solutions than how we did it on-prem as well. So taking into account all of those things, what does that mean and what should you be thinking about if you are an architect? So design for automation. If you think back to the very start when I was talking about infrastructure as code and DevOps and how you can scale up things and scale down them automatically, and also design for the disaster recovery and resilience as well. You should be thinking about how you can make things better and how you can automate as much as possible so that you're not having to sit there and click some buttons throughout the process. Be smart about the state of your data. So whether that's the state of storing your data, whether it's user data or system data, is the hardest part to really architect when we think about cloud native architecture. You should therefore think about architecting your system to be intentional about when and how and where you store your data. And think about stateless data as well, which means that potentially if it is stateless, it's easy to scale up and scale down, roll back, repair, load balance, etc. Whereas if you have stateful data, it can be hard to do some of that kind of automation and automatically managing your resources as well. So if it's not something you're aware of, have a look at stateless data and how that can help you with your architecture in the cloud. Take advantage of the managed services within the cloud as well. Try and remove the headache of having to look after the back-end software or infrastructure for some of these services. Look towards PaaS and SaaS services where appropriate. And again, try and make your organisation much more efficient when you're architecting these things. Defence in depth is something that we do have to look at and how we have to think about securing our environments. If you think about traditional architecture, we put a lot of importance on our perimeter security, crudely saying anything inside our network is trusted and anything outside our network is not trusted. Unfortunately, that made a lot of things very vulnerable to insider attacks or mistakes as well. If we look at cloud native architecture, it should be much more at the core, the whole security piece of it. And we should really look to actually secure each component, each part of our architecture against another part of the components. So I was talking to a customer yesterday who was saying that he's designed it so that some of his microservice architecture can only talk north to south, so up and down in his architectural diagram. It can't talk east to west, so it can't talk to the components that it sits alongside. Of course, that introduces some complexity, but again, it tries to mitigate some of the things that are happening inside your environment so that they are secure against other things that could potentially get attacked or be maliciously attacked as well. And last but not least, always be architecting. A design you did maybe 2 years ago could be massively out of date nowadays with some of the services and features that have been released and the new things that have happened. So constantly looking at how you can invest, how you can improve, and how you can make your architecture much better to take advantage of some of those newer features. Don't just leave a design that's sitting there and think that it's okay because you did it a year ago. Have another look at it and see if there's anything that you can improve upon as well. In summary, folks, look at introducing automation where possible. It does actually make your life a lot easier. Think about what you need to monitor and how it's important to your business and why you need to put the emphasis into monitoring it. Rehearse things like your disaster recovery playbooks and understand where, again, you can improve upon that, where you can get better, or where there's some massive issues in that playbook. And always be striving to improve. Look at how you can take on new features, new functionality, the new learning, the experiences you've had, build that in and continue to evolve your solution. If you need help with any of this, Cloud Direct can help you, so they can work towards operational excellence with you. They can help you implement infrastructure as code, whatever it may be. Do reach out to them and they can help you implement the strategies that you're working towards. Folks, thank you so much for listening to me today. There's lots of things that I mentioned that I could have gone into great depth in. However, if you take a look at the link on screen, you can find out more about them. There's lots of resources I've posted there as well. So yeah, thank you, folks. And yeah, is there any questions, Adam?
Hi, Sarah.
Oh, yeah.
No questions come through for the minute. Might not get any. But,
Nice.
That's okay. Cool. Thank you for that. I'm happy to end the webinar here.
Awesome. Thanks, Adam.
Cool. Thank you, Sarah. Thanks, everyone.